Okay, let's get started. Yeah. So I briefly repeat what I just said before. So basically, the right-hand side shows the structure of my code. So the three main things is the mapping and relocalization folder, and RGBD folder, as well as the external libraries.
What's the difference between RGBD and mapping and relocalization?
Yeah, mapping and relocalization is the application, which basically implements an API, a GUI, to use the to use the core functions of my dense SLAM system. While the RGBD is a library, contains all the source codes for tracking, map building, video source capturing, etc.
Okay.
So this application will depends on the library produced by this sub-project. Yeah. So inside the external libraries, I put the original source code of these third-party libraries here, so that saves you from compiling them. Yeah. So another folder it might be relevant is the data folder. That within here I stores the camera parameters, focal length in XY direction, principal point in XY direction, image resolution, distortion parameters, that kind of thing. If you switch to a new sensor, you should consider update parameter stores here. Okay. So let's get back to the to my application shows here, to my source code shows here. So as you can see here, each projects here, except the O build and the zero check, are the assistant project, assisting the compilation of the others. Yeah, there are 5 projects. So NIFI, zlib, and znz are say third-party dependencies.
Okay.
So mapping and relocalization is the application, and RGBD is the library.
Okay.
Yeah.
So basically, actually, mapping and relocalization is the function we're using, and which we should alter.
Yeah.
Okay.
Yeah. And so here is the main functions.
Yeah.
And it basically initializes Qt classes and allocate memories for them, and allocate a data class which stores all the data structures will be used by my application. So up to here, the application, the Qt application will enter a main loop. So everything will be started. But let me find the entry point for the code. So this is an init function. Let's see which one is data init. Right? Okay. Yeah. So for each multi-viewer class objects, and it will, after it construct the class, it will automatically call this init function, defines here. Sorry, no, here. So for each
frame or something.
Sorry about that. A bit confused here. Yeah, for each multi-viewer class objects, it will automatically call this init function, and the data class, the init function of data class will be called here. So here is actually the starting point of my code. So let's take a look at what happens inside the init function. So here's the definition of the data for your viewer class. So in my data class, I have 2 levels. The parent class is data for viewer, and the child class is the data life. You can see here the data life is actually quite simple. And so in the data viewer class, I stores the three main things. So the first is a video source to capture RGBD data, and the second is the cubic grid. Here, cubic grid class.
Why is it called cubic grids?
Because
Are you typing right now?
sorry, I didn't pay attention to your question.
So the first only the right two frames are working, and then you type something, and then the left frame.
Oh yeah, I tapped the R key to reset. R.
Okay.
Yeah. So you can find those information from my GitHub page.
That's why I was wondering whether it's just having the normal.
They're functional keys.
Okay.
No R. Sorry about that, but I will update this.
Yeah. Okay.
Yeah. So basically, you can see there's a red cube. This is the cubic grid.
Okay.
Actually, the big red cube was subdivided into many small cubes.
Into a KD tree or something, or
not KD tree. It's just grid.
Okay.
Grid,
For your metric
regular
grid.
grids. Yeah. So that's why I called cubic grids.
Okay.
Yeah. So yeah, we'll go.
But it's only one grid, right?
There are actually two grids.
Okay.
So one grid stores the dense surface data.
Yeah.
The second one stores the feature point. The second grid stores feature points. It's 4 times the resolution of the feature grid is 4 times smaller than the larger grid.
But sorry, I don't understand. What are the feature points?
So feature points are local signatures, records the patterns, image patterns of that local area. This will be used to establish matches given the query frame. So
is it true that from those points you create this mesh or this?
Sorry, say that again.
Is it true that from those feature points you then create the gray mesh?
Gray mesh. What
like
is gray mesh? No, no.
Okay.
So the gray mesh is generated using that cubic grids. So I also have a feature grids, let's say, and that feature grids only stores those tiny red dots.
Yeah, the special
so each
points.
red dots can be imagined as a signature of local area. So given a query frame, we want to estimate the camera position with respect to the 3D model. Okay. So this is the represents the camera location, the projection center, image plane. Yeah. So how do we estimate the position here?
Yeah.
It is we do it this way. We first extract another set of features from this input images. Then we use feature matching method to compare with each of the red dots here, and that will give us a corresponding relationship. Say this corner should correspond to, let's say, to this one, this red dot.
Yeah.
You know, and many of those correspondent relationships can be used to estimate the camera location.
Yeah.
Yeah. So all those features are stored in that feature grids.
Okay.
And that happens inside this class.
Can
so
you maybe go to this class then? Can maybe
Yeah.
see like how?
Okay. So here's the class. So
So the matching use point to point or point pair.
it's first matched using point pairs. Point to point is point to pair. Yeah. What's the difference between these two?
Oh yeah.
Yeah. So after the feature matching, you will have a list of pairs of points. Yeah. So here. So feature volume coordinates stores all the coordinate. So this is the feature grade. So this is a little bit complicated because this feature grade is actually store the index of feature. So because the feature are quite sparse, yeah. So we can't afford to allocate some memory for each one of them.
Okay.
So we only store an index of a cube. This is too much details. We'll go
Okay.
back to here later. Let's.
Well, what I'm just interested in, like because you create the mesh from the other grid, right? Not from the feature grid, but from the other volumetric grid. Because there are two grids, right, in this
Yes.
in this class.
Yeah, yeah.
Where is the other?
All of that too. There are two grids.
Yeah.
They all created using RGBD frames.
Yeah.
Yeah.
Yeah, but
It's
so
not like one grid creates another. It's not like that.
No.
So those two grids
Okay.
are created simultaneously.
yeah.
Yeah.
Okay, but the gray, like the non-feature grid.
Yeah. The dense surface.
Yeah. Where is that one stored in?
Where's that one stored in? Yeah.
Yeah, in
Okay.
this class.
Let me show you.
Is it this one, maybe?
Here, TSDF. So XY times Z.
Okay.
Yeah. GPU. So it's always stores in GPU. This is the CPU version of this one. Yeah.
Okay.
Yeah. So, and this one stores the feature grades.
Yeah.
Okay. Good. Let's go back to here. So the grade stores in the data viewer class. Yeah. Good. And the last very important class is this tracker. You know what? Let's move it together to make it looks better. These three are the most important, and this one can be removed. Okay. And this for viewer class or RGBD frame class are used to visualize the data contained. So, for example, this one PDAPS is to display this window, and the virtual camera is to visualize this window actually. Yeah. So on and so forth. You should be able to find a corresponding relationship between these two. Hi, Chris. No, it's okay. We actually record it so that later you can.
Awesome.
Yeah. All right. Okay. So let's go back to the innate class. Happens here. So inside the innate class, the glue, you remember the library glue is initialized here. CUDA is initialized here, and this also related to CUDA. And we load parameters from file. So let's go take a look into these files. So here it specifies the files that stores nearly all the parameters of the function. Yeah. So, and let's take a look at the. Yeah. Here's what's inside the parameter file. We call it the control.yml. So here specifies where your camera parameters are stored. So this two you can ignore that for now. So this you can ignore all this actually. So always keep resolution as 1, which corresponds to the QVGA format of image, and keep this fixed. That what you can tune is this parameter that describe the size of that red box. So currently it's 3 meter.
But I thought that the red box was just the bounding box around.
You can think it that way. It is a bounding box. We won't be able to reconstruct anything outside that red box.
But what would happen when you change that bounding box to be larger or something?
Yeah, then you can extend it a little bit further, but with reduced details. Because, like here, describe the resolution of the cubic rates.
Okay.
Yeah. So this each small cube is 3 divided by 400. Yeah. If you increase this into 5 meters, the size of each small cubes increase as well.
But is this meters? This volume
Yeah.
groups?
It's
Okay.
meters. Yeah.
So because I want to capture a whole room, so then I would have to make it. Maybe if I want to
So
capture
the
this
largest
room.
we test is 10 meters. You can't go
Okay.
bigger than that. And another drawback of increase the volume into that is you lose quite a lot of details.
Okay.
The other drawback is that it only goes in one dimension. So if your room is cubically bigger than
Yeah, you will waste a lot of.
Yeah, because if you have 10 by 10, of course, in the Z direction, you won't need that.
Yeah, that's right.
And it's kind of
You could
shitty, actually.
You could consider improve it by yourself. Yeah, make the cube into a rectangular box.
Mm-hmm.
Yeah, but yeah.
But how does it know how large it is? Because the model doesn't have scale, right?
The model has scale because this sensor gives you the
Scale.
absolute scale.
Okay.
Yeah. And yeah,
But the structure sensor doesn't have scale, right?
structure sensor has it has yeah.
But how? Because we only stream RGB and
The
the.
depth is the scale.
Yeah, the depth
Okay.
is up to metric. So
Okay.
yeah, that's here the parameter describe the initial position of the camera with respect to the cube.
Yeah.
Yeah. So
what is the orientation in that?
yeah, can you see that the red, blue, green thing? That's give you the orientation of the world coordinate system. Yeah. Red represents X, green represents Y, and blue axis. So initially the camera always align with that direction at the center of the cube.
And the Z being the forward-facing direction in the camera,
Yes.
the Y being the up and down, and the X being the left and right, according
Yes,
to the camera.
yes. Just take a look at here. You see? This X, Y, Z.
Gotcha.
Yeah. So, yeah. Here describe the initial position of the camera. So, you can change this with respect to your volume size. Yeah, you always want your camera in the center of your volume so that you can capture most of 3D geometries around. Yeah.
Mhm.
So if you say you change this to 5, let's do that quickly. You want to make them into 2.5, something like that. Yeah. Let's see what happens now. Okay. You see the feature get a lot sparser, and the details are not so great as the previous settings, and the box with respect to the model we constructed is bigger. Yeah. So yeah, that's that. So you can see here's the camera trajectory. Press F5. You have this. You can see that it moves from this point, which is actually the center, not the center, the position I described, 2.5, counting from here 2.5, 2.5, and that direction 1.5. Yeah. Okay. Good. So go back to this one. Yeah. Here we load all the parameters from this file, and then do some house cleaning thing to the folder that's supposed to store results, but actually I didn't store anything. So,
Okay.
so you can close the file. So init here. Okay. Okay. After load all the parameters, then it calls this function. It's actually very important. It reset the program by reset the OpenGL environment. Yeah, here also resets the OpenGL environment. So. So remember, in the data class, I have two layers. Yeah, the parent layer is called data for viewer, and the second one is data live. And so this reset function will basically load all the parameters, initialize the OpenGL environment, and here we'll initialize the video source or the RGBD sensor. So for Vega and JSON, you will want to change this code, probably completely replace this bit with the class that you built. So let's take a look at this function. So here we init the sensor driver. If we go into here, these are the old APIs of OpenAI that initialize some resources for the sensor, establish the USB connections, and start copying buffers, information to buffers, and load the buffer to my code. So this specifies the resolution of the sensor. You can ask the sensor to retrieve specific size of image, so you don't have to waste the bandwidth for the data that you actually do not need. So okay, you can also ignore this bit. This is supposed to load a coefficient for correct the nonlinear distortion of depth map. You have to do sensor. You have to do calibration for each sensor that you used. So in the end, this one was not actually used, and the non-distortion of the depth map is not that significant actually. So for most of your applications, I think it won't cause much difference. Yeah. So okay. Go back to here. So after you init Kinect, so these are the three modes of Kinect. You can initialize it as a recorder, so it will write the RGBD frame into a ONI format file, and this is to replace the ONI file that you recorded. But I find that when in the recorder mode, my code runs a lot slower. So in the end, I never used I seldomly use this too. Yeah. So this is the most important. Why not just remove this so that it is easier. Yeah. You basically allocate the memory for the video source class, init it, then that's it. So for this one, for the depths, each of the viewer class, you allocate memory here, and after you have the place holder for your RGBD data, you can now get the RGBD data. So by calling this function. So yeah.
Sorry, just a very stupid question, but is it still the idea that we're going to change this code for the structure sensor?
These are the bits that you need to change for the structure sensor, actually. So you need to probably write a new class, inherited the video source connect class. So override the init connect, reset init connect, and the get next frame. So using the APIs provided by structure sensor, something like that. So inside this function, yeah, here you need to call the APIs of structure sensor. Now I'm using the APIs of OpenAI, yeah, to load depth buffer and color buffer. Yeah. But when you switch to another sensor, you need to change this. Actually, I have an example which might be easier to explain. Real sense capture. You see here I have a video source RealSense class. This is the class. Okay, it's actually not even inherited the videos, but it's almost the same structure as video source connect. It has an init function and the get next the frame function. So, but this function is to load RGBD frame from a RealSense sensor, the one we are gonna use. So here's the init function for the video source RealSense sensor. So these are the APIs of Real Sensor. I will share this code with you. So, but you might need to make some changes. So you can see here I'm loading the camera parameters from the which contains the parameters of video sensor, real sensor. Yeah. So after the init connect is actually just called that init function. Yeah. So we can compare the get next frame. So this bit was replaced by the RealSense APIs. Yeah. So they store in OpenAI API. They store into this depth and the color buffer class. These are the format video streaming class. Instead, here the real sensor directly provide the what's that address of the buffer, of depth buffer as well color image. So later you just copy that depth buffer into this CVM depth class. These are the same thing. Yes. So basically you put the data from the buffer into that CVM depth, then your job done. And also you do that for depths and RGBD images. Does that make sense to you? Yeah. Okay. If you done that, then you can safely switch to another sensor. Yeah. Okay. Cool. So
the reset function You said we need to rewrite the reset and the initial and the get next frame. But the reset function is not what you write. Is just use a new pointer.
Reset is just the new. I think you confuse the reset of the shared pointer with the reset function of my code. So this inside this reset function, the reset function of this the reset function, yeah.
This reset.
Yeah.
I
it's
think
different from
like,
this reset.
Yeah.
This reset is because I'm using shared pointer.
Yeah.
This reset basically clear up the memory I allocated to that pointer. So yeah.
The next pconnect reset is use a new pointer.
Can you say that again? What?
This pconnect reset is use a new pointer.
Yes. Yeah. This is basically equivalent to. For a normal pointer, you would do this, yeah. For a normal C++ pointer, you would. Because it's not really normal, so redo source p10. Yeah. For the normal pointer, you would do this, yeah, because it's shared pointer. So it has a mechanism to automatically free the space once you finish using that pointer. But you need to allocate the memory in this way, calling the reset function.
Yeah.
Okay. Yeah. So after we set up our sensor, allocate the memory for the viewer class, and get the first frame. The first RGBD frame acquired by the code happens here. Yeah. Okay, we allocate the memory for the cubic grid, allocate memory for the tracker, and yeah. So here is the option I provided to go into a tracking only mode. That's probably relevant to Chris' project. And tracking, but usually my code just goes to this branch itself. So yeah, okay, initialize some parameters and then call the init function of tracker. So inside here we copy the memory parameters into the cubic grid class, because actually for tracker class, cubic grid class, RGBD frame class, they all need camera parameters, and all these parameters are identical. So you will see quite often that my parameters copied from one place to another just to propagate the same set of parameters from one class to another. Yeah, there's probably a better way to implement this, but yeah, this is the way I did it before. So yeah. So in this initial class, I start to extract 2D features from a black and white image. So okay, I forgot to mention this. So in the video source class, I create an image pyramid. So any of you guys familiar with the image pyramid?
No.
Okay. Yeah. I have a better way just to do this. Yeah. This is an image pyramid, basically a set of image with different resolution from fine to coarse. Yeah. So I have a pyramid of depths, pyramid of RGB image, pyramid of black and white image.
And that black and white image you get from the RGB?
Yeah.
Okay.
Yeah. I switch from calling a function of OpenCV, switch from RGB to grayscale. Yeah. So
You get the features from the grayscale.
yes, from the black and white, yeah, grayscale images.
Why not from the colored one?
It's because there's no major performance difference when you do that for color image,
Okay.
and you have like 3 times more
Data.
to process.
Yeah.
And in the end, we decided just
Oh.
use. Yeah.
Funny. I would think so. The other one.
Yeah. And then we extract that sort of 3D features by projecting the 2D features into 3D. Okay, this is yeah. Yeah. Just take a look at this image. So these are the image plane. These are the projection center. Yeah. So these are, say, this one is a 3D. Sorry, a 2D descriptor, because I have depth map. So I can shoot a ray by connecting these 2 points and intersect with my depth map. Yeah. Then I get that x1. Okay, and around that point I can get the 3D coordinates. Yeah, is that right? And also the surface normal of that point. Okay, you just memorize this.
Okay.
Yeah, so it's because I've already done that for you. You don't have to change anything to it. So yeah. So this function basically done that. Back project the 2D point into 3D, fetch its 3D coordinates and the surface normal. Just that. So this is actually not used. Suppose this is originally designed to load the pre-built 3D model, pre-built cubic grid from file. And I seldom use this. You can ignore this whole branch. Okay. Now, for the very first RGBD frame, we suppose the camera position in 3D are known. So, which means the rotation and translation are known. So this function is transform the depth map from the local camera coordinate system into the world coordinate system.
I don't understand.
Okay. So you can see here is the world coordinate, and the center of the camera is the camera coordinate. They are different. Yeah.
Yeah.
Yeah. So for the first depth map, it's
You assume it's in the middle of the cube or
yes.
center.
Yeah, that's right. So the raw depth is always defined with respect to this camera coordinate system.
Yeah.
But for the convenience of rendering, we have to transform those point cloud from camera to world. Yeah. Okay, just take that for granted. And because we assume the first frame, the camera position of first frame is known. Remember, we define it here. Yeah.
Yeah.
Yeah. So we can transform the depths from camera coordinate to world, so that we can place them into this big screen, big cube. Yeah, that function does that. And once we done that, we integrate the depth map. Okay. This shows the raw depth map. after transform from camera to world. Yeah. So this function is integrate this steps map into that 3D volume, the cubic grid class. So switch on this. Then we have this. Okay. So record the camera positions by calling this function. Is it record? Okay. To get the camera position using these two functions and store them into this vector. Yeah. Then you are done with the init function. Yeah, the init function is done now.
Shuda.
Yeah.
You mentioned earlier that you could load a cubic frame.
Yes.
So what exactly are you loading there? You're just loading a pre-built map, essentially?
Yes, pre-built map as well as the features, the 3D features, those red dots. Yeah.
And you have it set up so that it's possible to save that and load that
Yeah.
just with key presses?
Yes. I can't remember, but I can find it for you. This happens multi-viewer class. So all the key response functions are inside this multi-viewer class. So let's see which one stores the one metrics.
It's true.
Okay. Do I still have the store global features, store Nifty? Let's see. Export global function. Who is calling this function? Here. Okay. Capital letter C. Let me test that. No, it doesn't work.
They can do it, right?
Yeah.
Maybe I can make some of
It used to be this one. Oh, I might confuse this. Let's try it again. So one letter is to export, the other one is to import. Capital or lowercase, I can't remember. That function probably not working. No.
Export is lower.
Yeah. How do you know?
It said lower C.
Oh
after
yeah.
export.
Thanks. Press R again to reset. So press C to.
So if
Yeah. Let's take a look if we have managed to capture the. Sorry, what is your question?
I'll ask it after we get done with this.
Where did I store them?
Can you go back there?
Global model folder. Global model folder. Okay. I probably hasn't managed to store it. We need to create a global. Try it again. Nothing. Yeah, the storing function is not working, I think. Like, no, sorry, I don't know. It's been quite some time, but
Okay.
yeah, you probably have to debug it somehow.
Okay.
But basically, this function stores the surface data. This stores the key points, and yeah.
But can you maybe just quickly write to a CSV file or something, do you think, or not?
Sorry.
Can you maybe just, the cubic grid, if you can just make that write to a CSV file or something, or?
It's not that easy because the volumetric data is very, very large, and I need to first compress it, then store into a files. Yeah, so that's why this Nifty thing happens. So this Nifty is actually this class. It's a third-party library that's supposed to do that for me, and somehow it's not working. I don't know why is that. It should be just some minor bugs. But let's focus on just giving the overall structure of the thing. Maybe if
Okay.
you still have time, we can.
I can look into it later, but I did have a different question, which is when you start, if you don't have a first frame that's like if you cover the camera for the very beginning, it's not able to build anything after that, right?
No, yeah. So it will into the stage like this. So we don't have anything yet. So I just set it here. It's just stuck like this, unless you have a good frame. So a good frame is defined as you have sharp RGB frame as well as depth map with a percentage of area higher than threshold. Yeah. So but this shows that the initialization is not successful. If you pause this, you can see 2 less global features has been learned before. So what you can do is just to press reset and keep the first 2 frames, at reasonable good quality. Then it should work. Yeah. Yeah. That's it.
And the holes in the Connect, do you recall whether those are 0 or what value is placed into the black areas in the Connect?
Which one? Which black area? This one or this one?
That one. Down
I
there.
think
Yes.
0. I
0.
think it's 0. Yeah. Should be 0. And where are we now?
Is it different for the other? For the upper left-hand, the global view, is that a different value?
I
Is that
think
also
they
0?
should all be 0.
0. Okay.
Yeah. So here is the initial function of the tracker. So it have to find a reasonable good quality RGB frame, as I said, sharp RGB image with sufficient covering of depth map over the whole size, whole area. And if it is not successful, we'll enter this loop until it find a good one. Yeah. So
why, when you start it down there and then pull it up, does it not catch on, I guess, as it were, or do you have to reset it?
So there are actually an implicit requirements. That is the the first 2 consecutive frames has to be all good quality to establish the tracking. So if the first one is good and the second one is not, then it will lose track and gives you 2 black screen out here. So if not even the first one is good, it will get stuck within this loop. Yeah. So yeah, that's it. And so after this one, all the initialization is done. So automatically the QGL viewer class will call this draw function. The multi-viewer class will automatically call this draw function at frame rate. And as you can see here, this differentiate each individual frame. This is called global viewer, RGB depths, and predicted depths. Yeah. So for the global view subclass, it will call this update frame. So my SLAM function, the main function of my SLAM happens inside here. Happens inside upgrade the frame per frame, update per frame. So if I press P, which pause the SLAM, which basically set this value as false, so it will never, call my SLAM, so everything paused. And so this bit just copy the raw depths from the driver class, the Kinect video source Kinect class, into a depths RGBD frame and display it here. Yeah. These are all for visualizations, because I have this kind of thing. You can switch from one type of visualization to another. Yeah, and this is for that. This bit is for that. So enter here. Here is the main function of the tracking. So this parameter basically carries the RGBD frame and pass that into the tracking function. Okay, so we take a look at here. So we first use features to estimate camera initial position. That happens inside this one. And once that is successful, then we use this verify hypothesis and refine function to get a better estimation of the camera position. Yeah. If this function converts, then it will go into this bit. And this bit is again to transform the depth map into world coordinate and integrate that into the cubic grid. Yeah. So except integrate the depths, I also have to integrate the features, which are the red dots. This bit is to put those red dots inside the feature grid. Yeah. So after that you record your camera position, store your current frame for the use of next loop, and if the refinement function doesn't converge, which indicates the camera position has lost, then it will trigger the relocalization function here. Relocalize. So here is actually very similar to tracking function, except we use another set of parameters. For example, number of relocalization trials, and all others are actually the same. So if this one relocalization success, then it will return and update the camera position accordingly. If it is still cannot localize the camera position, it try to do that again using the next incoming RGBD frame.
Is there integrate in this one as well, or is there?
And can you say that again?
The integrate function.
No,
No.
we didn't integrate anything here because the relocalized position sometimes is not that accurate. So if the relocalization is successful, then from the next frame I will enter the tracking mode.
Mm-hmm.
And if the tracking mode success, then the map starts to be updated. Yeah. So then that's it. That's everything that I think you guys need to know. Yeah. So, any other questions?
Well, I'm just a bit worried now because, like for our projects, we have to finish half September, and we have to now start diving into this. But we've already worked 4.5 weeks on getting the RGPD, and I know it's not your fault, but I thought we were using this more as a black box, so we could really kind of, you know, we
Yeah.
don't have to code in this.
Yeah.
And I'm now getting a bit worried that if we're trying to make the structure sensor work with this, with our skill set, because we don't really know C++ that well, it's gonna take too long.
It's I don't know how to answer this, but
No, I know that, but
it's there's one way to bypass this issue is that you know, in my code, I think I can export them into a triangular mesh and pour them into a CVS file, as I did before for you.
Yeah.
Remember?
yeah,
And one way is you start working using that as input of your code.
yeah,
So in that case, you don't have to worry the details of this one.
so I
But
can just
if
use
you-
Connect.
Yeah, if you do require the real-time
I don't,
performance,
I don't.
then yeah, if it is not the case, then also I think you also need to talk with Andrew
Yeah, I'm
as
going to talk
early
today
as
about
possible. Yeah.
about it with him, but I just think that, you know, also debugging this and stuff like that, I think it's just gonna take us a lot of time, you know.
But I want to do this.
Okay, yeah.
Yeah.
I mean, for me personally, it's like I have to do some, you know, I haven't really been working on my own project yet, and I just need a point cloud or a mesh from the output. So yeah, I'd rather just
Yeah,
now
you have
say-
to talk with
Yeah.
Andrew because Andrew insists that you need your project needs to run in real time.
Yeah, but that's not needed.
You
Yeah,
have
I
to
will talk to him.
Talk to him, yeah, because he insisted.
Yeah.
And then to make it run in real time is actually a lot more difficult.
Yeah,
You know,
and-
you have to make sure your code is really efficient. Otherwise,
Yeah, but also
not-
time-wise, you know, we have 10 weeks now left. We have to write 90-page
Yeah, true.
thesis and everything, and we have
Yeah.
to do really research.
Yeah, true.
It's not realistic.
Yeah. Also, you need to understand CUDA as
Yeah.
well. So that's a
That's not
big
realistic
learning
in
curve.
10 weeks for us, you know.
Mm.
So I think now is a good time to say,
You actually
For me, it
encounter a
is-
similar situation as Jason,
yeah,
but we discussed a solution for Jason last week. Yeah, hopefully, yeah, you should also
yeah,
chase Andrew as early
yeah.
as soon as
Yeah, I'm going to meet him at 3:30. So
yeah.
talk about that.
For Vega, for you, it's actually easier. Right? Your main thing is just the communication between the iPad and my code. So if you can send the information in bi-direction, then yeah, it will be very nice because in these days the client-server mode of augmented reality is just the beginning. Yeah. So if you can show a demo that you can use your iPad and to do some interaction with the model built on the server side, and that will be very good. So you should more focus on the communication, you know, between the iPad and the
If I can successful do the simple communication and transfer a simple AR to the iPad, I have done the
yeah.
project.
You have to make sure the communication is reliable and efficient. That is the tricky bit, I think.
Yeah, reliable is doable, but the efficient, if I don't, yeah, I will investigate that.
Yeah. So, Jason, for your code, for your project, actually
Are you
is.
third master students?
Yeah, well, I'm doing
Do
the
you have
conversion
any
course.
questions
So I have this
on that?
conversion masters is a
I
1 year
wrote
course,
product.
computer
I
science.
think we
So I
started
at least
kind of
do a
last
new.
week and
Like,
yeah.
yeah, it's just that if I when I want to hack this kind of stuff and debugging and stuff, it's gonna take too long to start my own project and to write it.
It doesn't
What is your background or something?
So I have a background in electrical engineering, but I am currently a robotics PhD in the first year
Where did you study or something?
What
at Gonzaga University. It's in the U.S. It's
Okay.
Washington State.
And what is your focus on your
How to sample
And what kind of computer vision or something?
what paper are you talking about?
And SLAM then or something? Or
The paper we gave to you.
what's in SLAM or something?
But
Using neural nets to estimate the depth
I
instead
thought
of
you are gonna work on the auto
nice.
marker first.
And then
Auto marker is
But
a lot easier.
instead of having a
our
depth
marker
sensor or
has-
in general? Ah, okay. So you
has
just only have
code.
pictures.
Yeah.
So you have a drone maybe
Yeah, you
with
just use
a
it.
regular camera.
And as long as you can
maps out
estimate your
the
camera
world
position, use that marker, then
using
that
estimated
bit is
depth.
done. You should focus
Super
on that
interesting.
first. Don't worry
And-
about the paper.
but it's kind
You
of
should
interesting
always
also how
discuss the
depth sensors
content of the
becoming
paper with
more.
me. If you
Yeah,
comment
exactly.
anything,
I mean, I send this
Thing that
thing to
confuses you.
Andrew that they just want to add a depth
Get the
sensor
auto
or
marker
something.
working.
And,
and
but it's still
Just
interesting, I
put
think,
the
to also
markers
do it
code
only with
into your
pictures.
code.
You know.
and detect.
But then you would need a video
no,
stream
it
or
has
something
nothing
like
to do
that.
with my
Yeah.
code. You start a standalone
Ah, really cool.
product. Just
I'm gonna use deep learning or
taking
something,
an RGB image
Yeah,
as input,
just a
input
deep learning
and
the neural
estimate the
net
camera
to get
position
the
using the auto
depth
marker.
from
That's it.
single images.
Yeah.
It still captures the
Capture what?
就是那个还在录吗？
I don't know.